Hello everyone, here is a very short video for those of you who couldn't indicate the direction of the parametric curves here. I have a very basic examples of parametric curves. I'm gonna draw the graph of each of curves and then also indicate the direction of them. So now let's start with the first one. The first one, x is equal to sine of t and y is equal to cosine of t for t between 0 and 2 pi, right? So keep in mind always that sine squared theta plus cosine squared theta is equal to 1 when you wanna tackle this kind of problem. So therefore x squared plus y squared is equal to, just substitute x and y by sine of t and cosine of t, and then what you have is sine of sine squared t plus cosine squared t, so and it is equal to 1. Therefore the Cartesian form of your parametric curve is x squared plus y squared is equal to 1, right? So this is the unit circle. Now let's draw the graph of the curve. So when you want to draw it, so you can simply draw the simple you can simply draw the unit curve like that. Okay, so now it remains to indicate the direction of the curve. So to indicate the direction of the curve, you can easily draw your table for different values of t and then obtain the values of x and y. For example, put t to be 0, to be pi over 2, pi, and you can go ahead, but I think it's not necessary. By those points you could certainly find the direction of your parametric curve. So but you can easily go till 2 pi. So now, okay, if you take t to be 0, x is equal to 0 and y is equal to 1 for pi over 2. So x is equal to 1 and y 0, and for pi x is equal to 0 and y is equal to -1. So okay, it means that for t is equal to 0, x and y is equal to 0 and 1, which is this point. For t is equal to 0, for t is equal to pi over 2, so x and y is equal to 1 and 0. It means that here for t is equal to pi over 2, and for t is equal to pi, x and y is equal to 0 and -1, which is exactly here for t is equal to pi. So therefore the direction of your curve is this one, right? So suppose that you have a particle moving along the circumference of the circle. So at t is equal to 0, it is exactly here, and at t is equal to pi over 2, it is here. Therefore the direction of your the unit circle in that way. So, okay, now let's move on and solve the second example. So for the second example, you have so you have x is equal to cosine of t and y is equal to sine of t, and t between 2 pi and 0. So you can see that in the previous example, x is equal to sine of t and y is equal to cosine of t, but here we somehow change the place of sine and cosine. So by a simple computation, I believe, like the previous example, I believe you could easily get that x squared plus y squared is equal to 1. So therefore the Cartesian form of this parametric curve is the unit circle again. So again, you have a unit circle. So here we go. Right? Oh, sorry, it's not very nice. So, okay, could be better. But now, draw another one. So this is a unit circle. So, and so now to indicate the direction, you can draw a table for different values of t and then obtain the different values of x and y. For example, for t is equal to 0, pi over 2, and pi would be enough, but you can continue as I said before. So if t is equal to 0, then x is equal to 1 and y 0, and for pi over 2, x is equal to 0 and y is equal to 1, and for pi, x is equal to, for t is equal to pi, so x is minus 1 and y is equal to 0. So therefore what you have on the map is that, so take t to be 0, then x and y is equal to 1 and 0, which is exactly this point. For t is equal to 0. For t is equal to pi over 2, x and y is equal to 0 and 1, which is exactly here. T is equal to pi over 2. And for t is equal to pi, so x and y is equal to minus 1 and 0, which is exactly here for t is equal to pi. So therefore, the direction of the unit circle in this case is like that, right? Is like that. So as you see, in the first example, I mean in this example and in this example, the Cartesian form of both of the parametric curves are the unit circle, but the difference is the directions of them. The first one is clockwise, but the second one, I mean that this one is counterclockwise. So let's also solve the last example, C. So for C, we have x is equal to e to the minus 3t, and y is equal to e to the minus t. So as you see, there is no restriction given to us for t, but you can easily see that for any values of t, x is strictly bigger than 0 and y is also strictly bigger than 0. Therefore, there is no t such that x and y is equal to 0 and 0. So now what you have is just x is equal to e to the minus 3t. So this one you can write this one as e to the minus t to the third, and now substitute the e to the minus t by y, right? By y. So therefore here is y, therefore you have y to the third. Then the Cartesian form of this parametric curve is simply x is equal to y to the third. So if you wanna draw the curve for this, draw the graph for this curve. So for example, if x is equal to 1, then y is equal to 1, and if x is equal to 8, then y is equal to 2. So therefore you have 1 1 here, right? And here 2 3 4 5 6 7. For example, here is 8, and at 8 you have 2. Okay, so therefore you can easily guess that the shape of your curve is something like that, right? Is something like that. Okay, but remember that x and y are strictly bigger than 0. Therefore, here we have a hole like that. So we have a hole. So now it remains to indicate the direction. Again, just draw your table for different values and different values of t, and obtain x and y, right? So here, for example, put t to be 0, put t to be 1. You could also put t to be -1 as well. So if t is 0, then x and y is 1. So if t is equal to 1, then x is equal to 1 over e to the third, and y is equal to 1 over e. And if t is equal to minus t, so it's going to be 1 e to the third, and this is e, right? So therefore, if you take t to be 0, x and y is equal to 1 and 1, so which is this point, right? Which is this one, for t is equal to 0. For t is equal to 1, you have 1 over e to the third, and y is equal to 1 over e, so which is somewhere here, perhaps, for t is equal to 1. So, and for example, for t is equal to the -1, you have a point somewhere along here, here, right? For t is equal to -1. So therefore, as you see, t is equal to -1, the place of your particle here, right? And then for t is equal to 0, the place here, and for t is equal to 1, the place of your the particle is here. Therefore, the direction is that one, right? So I hope that this video is helpful for those of you who had a problem with the indicating the direction of parametric curves. Thank you very much for your attention.